Hey, hello class. In these sessions, we will learn something called templates. Using template, you can generalize functions and classes, which makes your code simple and easy to maintain. So templates are very powerful features in C++. Let's learn about these templates. C++ template allows you to define general functions and classes. This is very powerful tool. You can use it to remove duplicate code, which makes your code clean and simple. There are two types of templates, function templates and class templates. We will look at both of them in this week's sessions. Let's first look at the function templates. Let's assume that you are implementing swapping functions as shown here. So this is the function. The function name is swap values. Basically, this function swaps the value of the first and the second argument. So you receive two arguments here, and what it does is it stores the second values to first value. Let me explain again. So what this function does is it stores the value of the second arguments to the first arguments, and the value of the first arguments to the second argument. So it's just swapping the values of first and second arguments. And as you can see here, these functions receive int type of values. So it's swapping two int type of arguments values. So I'm sure this function will work for the int type of values. What about other types? Does this function also work with double types and character type as well? I don't think so, because it receives int type of values. So if you want to make swap value functions for a character types, you have to develop the another functions, or you have to overload these swap value functions. For example, like this, if you want to swap the other types of values, such as a char, you have to overload these swap values functions like this. So here we are overloading swap value functions so that it also works for the value of character types. So it received the character type of values, and just like a previous example, it's just swapping the value of first and second arguments. But this function works with character types of values. So this is the advantages of using a function overloading. So we learned function overloading before. We learned that this is the advantage of using a function overloadings. So by overloading of functions, now the swap value function can work with both int types and character type. So recall that C does not have a function overloading features. For C++, we have a function overloading, and here we overloaded swap value functions for int and character types. Oops, sorry. And because of that, now we can call swap values using a two int type of value, 1 and 2, shown in this example. And we can also call this swap value function using a character type of value A and B because we overloaded these functions. Here, char, and previously this one was int. So we can use these swap values functions for int type of arguments and character types of arguments. But this is not possible with a C programming language. So we learned that because there is no function overloading feature in C, you have to develop different functions for dealing with int type and character type. So shown here, these two are different functions because the name is different. It ends with I and this ends with character. So this function deals with integer values and this function deals with character values. So if you compare these two, this one is much better because we are using the same function name, but we pass different types of arguments. This looks better. For this one, we use two different functions for dealing with int type of values and for character types of values. So for this case, you have to remember all the function names for dealing with other types of values. So this shows the advantages of using a function overloading. But we want to improve more. Can we improve the code further? What can we improve? Think about it. We make the swap value functions better than before by overloading these functions. So now we can use swap value functions for int and character type. We are not developing two different functions for dealing with one and integer arguments and the character arguments. We are using one functions. So we improve the code, but can we improve the code further? Yes, we can improve the code further. If you look at these two overloaded functions, this function is dealing with int type of arguments, and this function is dealing with a character type of arguments. We understand that it is good that we could use swap values functions for both int and character type of values, as explained in the previous slide. That is the advantages of using a function overloading. But if you look at the implementation of these functions, these two functions, there are duplicate logics. This means that there are duplicate code. The red line in this example are showing that overloaded function consists of duplicate code. So they are duplicated. Only difference is this type of temp variables. How can we remove such duplicate code? Can we remove this duplicate code? Yes, we could do that if we can generalize these swap value functions. We can generalize these swap value functions by using template features in C++. So this example shows how to use function templates. As you can see from this example, the function definition starts with template keywords. This is called template prefix. This tells the compiler that follow is templates. So So swap value functions becomes the function templates. And T here is a type parameter, and we use a T instead of int or character here. So if you look at the original version of the swap value functions, we specify int here and character here. Instead of specifying int and character types, we write the type parameter t here. So we put t here. That's the differences between the ordinary functions and the function templates. So if this is the first time you encounter such template syntax, you may think this looks complicated, but in fact it is not that difficult to understand. Just start with a template keyword and use t where you specify the type. So we specify type here, int. So just replace type to this t. So this is how you make the function templates. So recalling the function template start with this line, template class T. So like this. Here the keyword class, you can think as a type. So type T. So you can think the meaning of this class is a type. And instead of using a class keyword, you can use a type name keyword as shown here. So it's your choice whether you use a class keywords or type name keywords here. It is your choice. And here, T, we say that it is a type parameter. T can be replaced by any type, including built-in types such as int, double, and char. And user-defined types such as a custom class type can also be replaced by this T. And you don't have to use a T. You can use any identifier such as A, B, or C. It's your choice. But we normally use a capital T here because it represents T. But there is one condition. You can use any identifier here, but you cannot use a keyword in C++. So rather than that, you can use any identifier here. So why we make function templates? So if you use a function template for swap values as shown in this example, this is a function template. The function starts with these template keywords, and the T here is a type parameter, and T is specified here. So we do not use int or char for the swap values, but instead we put the type parameter T. So when you call these swap values functions using a specific type of argument, so in this example, we are passing two int type of arguments here. The compiler will automatically generate the function definitions of the swap values that works with int type of arguments. So for your code, you only need to write this 1, 2, 3, 4, 5, 6 lines of code for swap value functions, compiler will automatically create necessary swap value functions for you. So in this example, because we call the swap value functions using 2 int arguments, the compiler will create the swap value functions that receive 2 int type of arguments. If you call a swap value function with other types of values, such as a char, then the compiler will also create the function definition of swap values, which works with char type of argument as well. So using function templates, you can remove duplicate code. Now you don't have to write the swap value functions for integer types and the character types as you saw in the previous example. You only need to write these 6 lines of code, and compiler will generate necessary swap value function definitions for you. So by using these function templates, you can remove duplicate codes. Let's look at the demo code for using template functions. This is the demo code. We have one function template. The function name is swap values. We already talked about these swap value functions in the previous slides. So instead of writing actual type, such as an int or char, we specify t here. We learned that t is a type parameter, and we also put t here. And this logic is just swapping the value of first and second arguments. So this is the function template. And function template starts with these template keywords. And by the way, we learned that you could use the type name here. Whether you use a class or type name, it's your choice. So, but here we will use a class keyword. Inside of these main functions, we declare 2 integer type. It prints the original integer value, so this line should print 1 and 2. And we are passing these 2 integer variable to the swap values. And after that, we print these integer values. For this one, we are creating the character types of 2 variables. This one stores A and this one stores B, and it prints the these 2 character types of variables. And this time we pass this character type of variable to these swap values functions. So let me compile this program first and see its output. Template function 1. It compiles well, and if I run this program, it prints this 4 line. It first prints original integer 1 and 2 is this one. As expected, integer 1 is 1, integer 2 is 2. And second line, the swap integer 2, 1 is this one. Now the integer 1 is 2, integer 2 is 1. Because we pass these 2 variables to these swap value functions, which changes the first and the second argument values. So that is the reason why integer 1 stores 2, integer 2 stores 1 here, because of calling this function. And here we are creating another two variable type char. The first one stores A and second one stores B, so that is the reason why it prints 1 for A, 2 for B, 2 for B here, so 2 for B. And we pass these two variables to the swap value values, and this function swaps the first and second arguments values. So now char1 is a B and char2 is A because value is swapped. So note that here we pass these two integer types of arguments, and here we pass these two character types of arguments. So this function works well for both integer and character types. This is possible because we use the type parameter here. So for this one, compiler will, because we call these functions using this two integer, and we call this function with two character, if we write this function template codes, the compiler will automatically generate swap values functions for works correctly with two type of arguments. And because of this function core, the compiler will also generate the function definitions for swap values, which works correctly with character types of two arguments. So compiler will automatically generate for you. What you need to do is just this 1, 2, 3, 4, 5, 6 lines. 6 lines of code. The compiler will generate for you the other part of the function definitions. So this is a power of using template classes. If you do not use a template classes, you have to overload these swap value functions for integer type of argument and character type of arguments you saw in the previous slides. So let's go back to the slides. Okay, let's look at another example of function templates. Like a previous example, the function starts with template keywords and type parameter t here. This time the function receives 3 arguments, 1, 2, 3. And the type of the first argument is int, it's fixed. And we use the type parameter t for the second and third arguments. And the definition of this function is this. It just prints the value of 3 arguments, step1, step2, and step3. If we call these show stuff functions like this, the compiler will generate functions by replacing type parameter t with double. So because 3.3 and 4.4 is double typed, the compiler will compiler will replace this t to double. Note that for the first arguments, we explicitly specify int, so you can only pass int type of value as a first argument. You cannot pass other types of values. But you can pass any type for the second and third type of arguments. The compiler will generate function accordingly. So the output of these functions core is this one. It just prints the value of 3 arguments. But note that for the second and third argument, we use a type parameter. So instead of passing the double here, you can pass any other type, such as a char here, or float, or int, or string as well. The compiler will generate the necessary code for you. All you need to do is just write these function templates. When you are using a function template, there is something that you should be aware. Note that for the programming assignment 1 and 2, you declare the member functions of the classes in the header file and the actual definition of member functions in the separate other file. That's what we typically do in C++ programming. Separating the declarations and the definition of the function into different files. But many compilers do not allow separate compilation of templates. So it is safe that you place template functions definitions in the file where it invoked, or at least the function declaration must come before the function invocations. And one way to achieve this is use the sharp include directive and specify the file that contains the template function definitions before you invoke the template functions. So you must be careful about this. The compiler may complain of your code if the function definitions of the template functions is not in the same file of the function invocations. So you need to check your compiler. Some compiler may have additional requirements for using templates, so double check it when you have to use templates. Okay, that's it for these sessions. We will talk more about the function templates in the following sessions. So see you in the next sessions.